Alright, hello students, this is video 7.15. The unit title is Algebra Hot Topics. The objective is I can solve quadratic equations and geometry problems. Alright, let's go flippers. So, when you're solving quadratic equations, we're actually going to be solving them by factoring. Okay, and many of you have seen this before and you remember from algebra, but we need to be specific so that we know how to do this always and all the time. So, one type of equation is a linear equation, and you've seen a lot of those. And the form of those look like y equals mx plus b. So a couple of linear equations could be y equals 3x plus 4. That would be an example of a linear equation. Now, quadratic equations are different, okay? And quadratic equations are different because right away when you look at the standard equation, which is what you're looking at here, y equals ax squared plus bx plus c. The fact that this is x squared is going to indicate that there are going to be possibly multiple solutions for this type of problem. And the multiple comes in with this exponent, which is a 2. So that's why the answers to quadratic equations are often known as roots, solution sets, or zeros, because there's multiple solutions most times. Okay? An example of a quadratic equation other than standard form would be y equals 2x squared plus 4x plus 5. Okay? The really cool thing about linear equations and quadratics is when you graph them, you can tell from graphing them what their behavior is. So a linear equation actually makes a line. So a beautiful line. Whereas a quadratic makes a parabola. And where that parabola crosses, and I'm going to draw in the x and y axis here, where that quadratic crosses the x-axis, those are usually those roots, solution sets, or zeros. Okay, that's why I said it usually has two solutions, but there are cases where it has 0 solutions, because they're imaginary. There are cases where it has one solution because it's kind of a double repeated solution. But again, for our case and purpose, what we'll be using is they'll have two solutions where one will be positive and one will be negative, and because this is geometry, we are going to use the positive solution. Alright, so let's actually start off with this quadratic equation. Right? And it says first we want to write the quadratic equation in factor form. So here's a quadratic we're going to start with, x squared minus 7x equals negative 12. And then we're going to give the solutions to this equation. So right away if you look at it, it doesn't look like this equation that we started with earlier, our standard form, where we had easily y equals, okay? We want to get this equation so that we have everything on one side and it's equal to 0. So let's do that. And we do that by going ahead and adding 12 to both sides. Once we do that, we're going to end up with x squared minus 7x plus 12 equals 0. So now we're ready to actually factor this and solve it. And the way that we do this is we're using a technique called x factor. And x factor actually says you're looking for two numbers, and those two numbers have to meet two conditions. The first condition that has to meet is that those two numbers have to multiply to 12. So we're going to put 12 at the top because we're looking for numbers that multiply to 12. And those two numbers also have to add or combine to make negative 7. So we'll use blue, negative 7. We're getting that number right there from what's in front of x. And again, that would be your B, and then the 12 would be your C. Okay? So what you do is you literally just go through and think about your factors. So I'm going to try two numbers that I think would work, and I'm going to try 6 and 2. Well, 6 and 2 absolutely multiply to 12, but they don't add or combine in any way to negative 7. So those two didn't work. So let's try another two. What about 3 and 4? So 3 and 4 definitely combine to give me 12. They multiply to give me 12. Very important. So I've met condition here, right? Where they multiply to give me 12. But 3 and 4, the way they are, don't actually combine to give me negative 7. But if I make them both negative, I will get a negative 7. So those are my two factors I was looking for. So let's actually rewrite this in factor form. Take the numbers that I've just found and I write them inside of parentheses with x. So x minus 3. The quantity of x minus 3 times the quantity of x minus 4. All of that equals 0. Now I have two smaller linear equations that I need to solve. So I'm going to say x minus 3 equals 0. and then x minus 4 equals 0. Now I'm going to solve them by adding 3 to both sides, and here adding 4 to both sides. To do that, I'm going to end up with x equals 3, and over here x equals 4. And those are my two solutions. So sometimes you see it written inside of brackets, so it'll be 3, 4, which means there are two answers to this problem, 3, 4. Sometimes people leave it like this, x equals 3 and x equals 4. Look at example number 1. So example number 1 says, solve for x squared, x squared plus 2x minus 24. So this is already on one side and 0's on the other, so we're already ready to start. So we can immediately go and start x factor. And again, x factor says it has to multiply to negative 24 and combine to 2. So I'm going to think of the two numbers, obviously, that are closest to each other that are factors of 24, and that would actually be 6 and 4. So I need to make one of these negative, and at the same time, when I combine them, I need to get a positive 2. Since that is the case and 6 is bigger, I will leave 6 positive and I will make 4 negative. So now when I write this, I'm going to go x minus 4 times the quantity of x plus 6 equals 0. Now I'm going to solve both smaller linear equations, writing them both out. And then when I do that, I'm going to end up with, over here, x equals a positive 4, but on the right side, when I subtract 6 from both sides, I'm going to end up with x equals negative 6. And if this was the geometry problem that you were solving, only one of these solutions would work. That would be the positive one. But this is just quadratics. We're not giving them any application, so there are two answers. One is 4 and one is negative 6. Let's look at question 2. Question 2, looking at it right away, x squared equals 16x minus 28, not set up to solve right away. So we need to actually get everything to one side so that we have 0 on one side and everything else on the other. So let's actually subtract 16x from both sides, which would give us x squared minus 16x equals negative 28. And then let's actually add 28 to both sides, which would give us x squared minus 16x plus 28. Now equals 0. We're ready to solve this. I'm using x factor, and I'm looking for two numbers that multiply to give me 28, and they combine to give me 16. So 28 is a tricky number. There's not a lot of factors for 28. 7 and 4 obviously can't combine in any way to give me 16, but 14 and 2 could. So if I've got 14 and 2 and I multiply, I'm going to get 28. But if I make them both negative, they can combine to give me negative 16, and they multiply to give me 28. So I've got x minus 2 times the quantity of x minus 14 equals 0. And now I'm going to set both of those equal to 0 and solve them separately. I'm going to do one up here, one down here. X minus 14 equals 0. Adding 2 to both sides here is going to give me x equals 2. And adding 14 to both sides here is going to give me 14. Therefore, my two answers are 2 and 14. The last problem has a lot of stuff going on. So if you look at it, it's already kind of in factored form, which is great and awesome and wonderful and everything. But we kind of need to get all this together. So what's going to happen is, unfortunately, we have to actually go ahead and FOIL this out or distribute it so that we can actually combine these right side terms with the left side terms. If that's the case, we have to actually do x times x, which gives us x squared, and then x times 3, which gives us 3x. Then negative 3 times x, which gives us negative 3x. And then negative 3 times 3, which gives us negative 9. And all that equals 6x minus 14. So now you kind of see what I'm saying. I needed to make these into terms without the parentheses so that I can combine these with them. And then we're going to get everything on one side equal to 0. So let's keep going with this one. So now we're going to combine what's on the left, that's right. So we've got there 3x and a negative 3x, which becomes 0. So that's just x squared now minus 9 equals 6x minus 14. And now I'm going to subtract 6x from both sides so I can get these X is all on one side, so I've got x squared minus 6x minus 9 equals negative 14. And now I'm going to add that 14 to both sides. And so now I'm pretty much where I want to be. X squared minus 6x. This is going to be plus 5 is going to equal 0. And again, that's where I want it to be. So now I'm ready to use x factor again. So I'm going to set up my parentheses because I know they're coming. And I'm going to write my x factor. This time it has to multiply to 5 and combine to negative 6. Well, this is a little easier because 5 is a prime number. There's only two factors that we know of, 1 and 5. Hey, that works. You get 1 times 5 gives you 5. But 1 times 5, 1 and 5 don't add up to negative 6 unless you make them negative. So now, negative 1 times negative 5 is 5, and negative 1 plus negative 5 is negative 6. Add those into your parentheses, x minus 1, x minus 5. So we've got x minus 1 equals 0, and x minus 5 equals 0. And if we add 1 to both sides here, we get x equals 1. And if we add 5 to both sides here, x equals 5. And our solutions are 1 and 5. All right, and here's a secret hot question. It says, find the solution set of x times the quantity of x plus 8 equals negative 12. This is a nice problem. You've got to do a little distributing. You got to move some things to all the same side. Make sure it's set equal to 0. See you tomorrow.